Hello there, welcome back. I don't know what happened. I was playing guitar before I started recording this video, so you get that little bit of improv. Alright, so last time we've worked on reading the config file from disk, and today I just want to do a quick thing where we go ahead and parse that config file. So let's get started. Right, so first of all, I think I'll start by just commenting out the memory map. So I'll go ahead and do const let me call it something different. Bootloader config, and I'll have a function called parse config, to which we pass the config as a nullable. Yeah, looks okay. Right, so I'll go over here and do fn parse config. That takes a config, and our config is a optional const u8 slice, right? And this returns, we need to return a struct, so let's call it bootloader config, something like this. Right, I guess we need to define this bootloader config somewhere. So for now, let's just put it over here. So const bootloader config is a struct. And this struct has a kernel, which is a const or a slice of const u8, and we will have a I guess we could call it video for now, and this would be a struct, an anonymous struct that has a width of type u16. I don't think we need any more than u16. Yeah, that should be fine. And a height, which is also u16. Right. Okay. I actually want these to have default values, so let me just go ahead and initialize those here. So the width, I want this to be 640, and this I want to be 480, and of course this would need to be default initialized, so basically has 640 and 480 for the value. Okay, so we have our bootloader config there, so we can just go ahead and start working. Right, so the first thing I am going to do is just create a logger. So std log scoped, and I'll call this config parser. That looks okay. So let's check first that, or rather, let's first of all create a variable, bootloader, let's call it parsed. This would be of type bootloader config, and it will just be default initialized, right? So if the config is not null, and we capture that in this capture variable here, let's call it CFG. CFG, there we go. Right, and either way, we are just going to return parsed. So the idea is that if we have a config here, we go ahead and parse it, and we change the values in this parsed struct here, and we return it either way. Either if the config is null, or we don't have a config, we will return the default values. Otherwise, we are going to just return the correct values. And actually, if I am to ever revisit this, I would probably have this return an error, because I don't think we want this to have default values. Just doing this for the sake of simplicity for now. But yeah, so here, if we go here, we can see that the kernel is basically an empty string, which is not really good. So an error might be the way to go, but for now, I'll just keep it this way. All right, so now that we have our config, I guess the first thing that we want to do is, so every single config line is of type, so let me just do this. It should be something like key equals value and then a new line. So I guess the first thing that we need to do is split the config by the new line character. So let's do that. So actually in the Zig documentation, there is under stud mem, there is a split thingy here. And I think this split is deprecated. Yeah, it is. So we might want to use, so it says it here in this. So split sequence, split any, or split scalar. I think we are interested in split scalar since it just takes one delimiter of type t, which is what we want. And there is another variant which is tokenize. Let me just take tokenize scalar for now. So it takes pretty much the same arguments. The only difference is given repeating delimiters, like in this example here, it will basically skip all of them, whereas the split, so here we have an example of split with the pipe character, and this will actually return a empty string here for this element between the two pipes, which is this one here. So after def, if we call next on this iterator, it will return an empty string and then ghi. So that's the main difference, I think, between tokenize and split. So yeah. Right, so for our purpose here, we actually want to skip all the new line between, that might happen between two lines. So let's use a tokenizer. So var, I'll call this line tokenizer, and this would be, so stud mem tokenize scalar, and this takes a type for us, let's say U8. It takes a buffer, which is our config, and it takes a delimiter, which is, we know it's just a new line character. Right, so that returns a token iterator, and now we can just go ahead and do while. So line tokenizer dot next, and we can capture that. Let's call it line, for example. So now we have every single line here. And what we want to do is now split the line to a key and a value. And this would just be a simple split. So let's call that kv split. Actually, this should be snake case. So tokenizer. So kv split iterator, and this would be stud mem split scalar, I think. Yeah. So it will also take a U8. It will take line, which is our buffer, and it will take a delimiter, which is the equal sign. Right. So here we just need to do an if, and we just want to check that this .next basically exists. We capture that in key, right? And then we are going to create const value, and to this we are just going to assign kv split iterator.rest. So we just basically take the first split item and set that as the key, and then anything after that is our value. Right, so now we need to do a few things with the value, and I think the first thing I'm going to do is do a check to see if the value is, I think it's kernel, but let me check. Yeah, so if the value is kernel, then we take, or rather, if the key is kernel, then we take that value and put it in our parsed struct here. Otherwise, if it's video, then we might want to parse this again and just extract the width and the height from it. So let's do that. So here we'd like to do stud mem equal, and type is U8, and we want to check that key is equal to kernel. So if that is true, then we just go ahead and do parsed.kernel is equal to value. Yep. Right. Otherwise, if instead of kernel we have stud mem equal U8 again, key is what's the other one? Video. Right. So video. Then here we parse the video resolution. Right. Is there anything else that we need to do? I don't think so. So let's parse this. So here again, I'm going to just take a I guess vid resolution tokenizer, and this would be stud mem tokenize scalar takes a U8, and actually I'm not sure that we need a tokenizer for this. I guess we could just split it once, because we know that we will have exactly one split point, right? So I guess we can just do vid resolution split iterator, and this would be stud mem split scalar of U8 value, and the character we are splitting with is the X character. So basically here video resolution should be format with X height. For example, something like 600 times 480, for example. Right, so now that we have this, we should check that we have something in that. Capture that, so that would be our width. And then I guess our height would just be the rest of that. So now we have a few things to do here, because we need this width here would be well, it says unknown for some reason. Oh yeah, because this is missing. Right. So now we should have there we go. We have types here. So W is a basically a string, a U8 slice, and H is also a U8 slice. Whereas we want a width and a height that would be U16s. So let's convert the string to U16, I guess. So I guess we can do something like this, and I think there might be something instead. I think it's format parse int. There we go. What does that take? It takes the type, a string buffer, and a base. Okay. Okay, so if we pass 0 to base, it will try to auto-detect from prefixes. Okay, right, that's pretty cool actually. So stud format, what was it? Parse int. We want a U16. We want to parse W, and we know that it's a base 10. Not gonna let that to be auto-detected for now. And we can see here that this returns a parse int error. So that's this one here, a parse int error. So let's handle that error, I think. So we'll catch, and we will log something. So log error. Parsing width should be a valid U16. There we go. That looks okay. Right, so let's do the same thing with height, I guess. So we can just do so width becomes height. There we go. Oh yeah, we just need to change the W to H. And that looks pretty good, I think. Right, so here we might want to put in some error handling, because if we can't get the video format, it means that the format is not good. So let's print an error, and this error would be expected resolution to be, I guess we can just do something like this, but found, and this I think is something we have. It should be value. Right. Is it value? Yeah, it is value. So it's what we are trying to split here. Right. So let's go back here and do parsed dot video equals, and we are going to set width and height. Oh, actually, this is not Rust. we are going to have to do this. There we go. And with this, I think we should have something to try. Right. So I think we just need to do something here. If we hit an error, we should return something. And I think what I'm going to do is just make this an optional. Return null. Same here. There we go. Okay. I think that should be good. So let's write some code that uses this, because otherwise we are going to have this annoying unused local error. So if bootloader config captured as CFG again, I'm not too fussed about that. Right, and we are going to do log. Yeah, we don't have a logger here, so we need to do std log info and config parsed config file, and we put in a kernel file, something like this. This would be a string, and then we go back to line, and then we do video resolution, and this would have to be so an int x, a second int. Yeah, it looks okay. And then here we go ahead and do config.kernel, and then config.video.width, and then config.video.height. There we go. All right, so let's build this and see what we get. There we go. So it built without any problems, which is pretty rare, but okay. So let's run it and see. Okay, well, it looks like it went freaking well. First freaking time. Right, so 600, 480, that looks good. So let's try to actually trigger some, that's not it, this is it. So let's try to trigger some error. Let's add some weird character there. I guess we could, we need to repackage the disk. Okay, so we have an error. Actually, hold on, where did I put that? There we go. So I just want to add here just this, and that would be W, I think. And this one here would be H, and we'll just do something like this. Pretty good, pretty good. So let's try something else. Let's try this. Okay. Right, so I guess this error here doesn't make sense. Because the only reason we are going to get there is if this returns null, basically, and this can only happen if we can go into that. Okay, so if the index is null, and the index is set to null if what's this condition here? Right. So if we reach the end without ever going through this, or if we call next again, yeah, if we reach the end and call next again, it will be null. Since we are doing it just once with an if instead of a while loop, I think we can just forgo this. It doesn't make sense to keep it. Right, so let's try something else here. Let's try, so 1961 times 180. Yeah, that looks pretty good. So I think our parser is looking okay. Actually, this one thing I'm just seeing here might cause a problem, which is this kernel path. In our BIOS bootloader, we didn't put the dot here for the extension, but I think that's a problem for future me. So good luck, future me. Well, that was it. We have parsed the config file, or at least the portions that we are interested in. As always, if you like this type of content and you want to support the channel, leave a like and a comment, and maybe share the word. I appreciate it. And until next time.